Today we will work on our project called Obstacle Avoiding Robot prototype of Tesla. In this project, our robot detects the objects and change its path accordingly. The component and materials we will use in this project include a USB cable to program our ESP32, some jumper wires, and ultrasonic sensor. All of these required components are included in our kit. Now let's take a look at our programming. Include ESP32 servo.h and include newping.h. These lines include two libraries required for the program: ESP32 servo for the servo motor control and newping for the interfacing with the ultrasonic sensor. Now our constant int left motor forward is equal to 27, constant int left motor backward is equal to 26. These constant defines the pin numbers connected to the motor driver, specifying the directions forward and backward for the both left and right motor. Then our defined trick pin is equal to 5, define echo pin 18. These constant specify the pin numbers connected to the ultrasonic sensor for trick pin and receiving echo. Define maximum distance 200, boolean goes forward is equal to false, int distance is equal to 100. Here the maximum number set the maximum distance ultrasonic sensor will measure. Goes forward is boolean flag used to track the robot movement directions. Distance is the variable to store the current distance reading from the ultrasonic sensor. Newping sonar and servo motor. These lines creates instance of the newping and servo classes, initializing the ultrasonic sensor and servo motor objects. Now our void setup. In the void setup function, it sets the motor pin as output, attach the servo motor to pin D15, initialize the position servo position 115, delay and reads the initial distance from the ultrasonic sensor multiple times. After that our void loop. In the loop functions, it declares the variables for the right and left distance and introduce a delay. Then our if loop checks if the current distance is less than or equal to 20. If true, it stop, move backward, stop again, look right and left, and decides whether to turn right or left based on distance. If false, is continuous moving forward. Update distance variables with the latest ultrasonic sensor readings. Then our void move stop, in which our programming we can see int look right, int look left, int read ping. These functions control the servo motor to look right left, measuring the distance during the process. The read ping function read the distance using the ultrasonic sensor with the delay. After that our void setup, in which the void setup we can see void move setup, and then void move forward, void move backward, void turn right, void turn left. These functions control the movement of robot, stopping, moving forward, backward, turning right and turning left. The direction and duration of the movement are specified using digital write and delay. Our programming is completed. Now let's compile our program. During the compilation, the program IDE checks for any error, and if there is any error, it highlights the respective lines. Once the compilation is successful, we upload our program to our microcontroller. Before giving the upload command, make sure to connect your ESP32 to the laptop or PC using a USB cable. Then select the appropriate board and port. Our board is ESP32 and ESP32 DV module. Then we select our port and proceed with the upload process. When the term connecting is mentioned in our commands, we need to repeatedly press the boot button on our microcontroller ESP, and our program is uploaded. Our programming has been uploaded to our kit. Now let's connect our jumper wires to complete our projects. First, connect the pins of ultrasonic sensor. The ultrasonic sensor has pins labeled for VCC, echo and trig. Match these pins with the corresponding pins on our kit and connect them with 4 jumper wires. VCC to VCC, ground to ground and echo to echo pin. Connect echo pin. First, take 2 jumper wires to connect echo and trigger pin with microcontroller. Female to male jumper wires. Gray wire is our trigger pin. Trigger pin connect with D5 and echo pin with D18. Next, connect the 3 wires of servo motor. These are the wire of servo motor. Yellow wire with SIG, red wire with VCC and brown wire with ground. Match these with the corresponding pin on our kit. Then connect the signal pin to D15, SIG pin to D15. Afterwards, connect the motor controller pins to our ESP32, D27 to D33. These 4 pins connect with in 1, in 2, in 3, in 4. This is our motor controller IC and its pins are there. And connect in 1 with D27, into D26, D25 and then D33. Collect also EN1 and EN2 motor controller IC pins with VCC 5 volt. Now that all the pins are connected, let's power on our kit. Just as we can see, our robot is detecting objects and change its path much like Tesla car do. Today our project concludes.
right here.